I don't know. I'm like the guy when they like say scalpel, I just end it.
Man.
Honestly.
Shit up.
I did it.
Oh shit.
Don't lick it though, because then it's gonna get all it's gonna get wet and it's not gonna come out.
That's like my teeth. That's like a cool job.
You're gonna struggle the whole time you want to do this. Demi, I know you don't want that to become mine, right? Whoever doesn't get away from it will be mine. I got pink phone right there, and this iPhone right here,
That went too far in there.
and that phone right there. All that can become mine too. This is the Dead President soundtrack. Hold those up behind me. Just keep backing up on it. Whatever.
I don't let any people walk behind me. He's like, why not? There's a 70% chance I can text him back. Well, at least a 30% chance I can text him. And he's like, let's come from the phone. At least I can see him. He just smacks me.
Every time we take a quiz, you
Cheat all the time. Now you've got all the answers.
Let's go over this real quick. Actually, you know what? No. Yeah, but I probably end up choking on that.
I've got a good aim, that's why.
Yeah. Probably hit me in my tonsils or something.
If you hit you in the tonsils,
That's what? I don't know. Thank you! Louise, help me out, please. What is a sampling distribution in your own words?
I think I got something. I think I got it wrong. I didn't have the wrong idea.
Who got sampling? You want to go for it? Go, Gabby. Gabby.
Every possible statistic in a sample.
Not in the sample.
Right.
In the population. Over, what do you got? Hold on, did you use your notes?
Oh, what's that? I'm just not even gonna talk. I didn't know steps.
It's a quiz every time. Everyone.
Well, I mean,
I kind of know, but it's easier to say I'm sorry than to ask for permission.
I'll be going to admit to the cheating.
I can't even hear it, guys. Be quiet, please. Stop.
Get out.
Chase over.
I know, that's like my reaction right now.
Oh, I would say. Go. What do you got?
Leave. No one wants you here anymore.
Shoot fly. Don't bother me.
A sampling distribution is all possible samples in a population.
Yes. Yes. Good job. So yeah. What else is there to say? Next one, the symbols. Let's go with Ben. You want to do the first one? Mike.
He's just picky random.
Is that mean of a population?
Good. What else can I call it? The true mean. If I say that's the true mean, then I also know that that is the mean of the population. Mean by itself, no. I mean, we know it's a mean, but which mean is it?
What if we didn't mean?
Because that's also the mean.
What if we didn't mean and then put parameters?
What if you didn't mean the mean?
What if you meant the mean? So what if you put mean and then parentheses and put parameters?
That's fine. I'll take that. Oh, you're mean. You're nice.
You're not. The true mean or the
The mean of a parameter is the true mean. Okay? This one? Of
The sample.
a statistic, of a sample. Good. Okay?
Alright.
Well, yes you do, because this is a mean and that is a mean. If you just said mean, then
That keyword, you
Well,
probably
they're like, it's once for a parameter, once for a
well,
statistic.
you're gonna need to know the difference.
You need to clarify what you mean.
you know what I mean?
So, anyways, standard deviation for a sample. How about P? What's P? Proportion? Parameter. Okay? So, what do X bars mean of a sample? This one is the proportion of a, yeah, so you can call this, yeah. And then finally the, right, so you can call this the, oh, that's actually a true standard deviation, right? So it's a true parameter. A true parameter, is that redundant? Okay, cool. All right.
So you're gonna tell me that I spelled all those wrong?
No, I'm just not going to tell you that you didn't get any of them right.
No, like their hair, like right from the cat.
Well,
It's just like falling, like rain. You get it right.
love you long time.
This is okay. So this is your leg. Big old crap.
Oops, no.
That's you. So this is you from the back. So you have hair like this, but
Okay.
nothing really.
Thank you.
Like hair from the ring.
Francisco.
Just curl it around right.
Why are you talking to everybody? Stop distracting the people around you. So Monday we started talking about sampling distribution. I'm going to hit it again really quick because there's some other problems in this presentation that I really like. And yes, you do need to know the difference between the parameter and the statistic. Okay, because remember how we were doing z-scores? You guys remember the z-scores?
Yep.
And we needed we needed the mean, and we took away from that the data divided by standard deviation. It's going to be something very similar, except you're going to not be using, it's the same idea, except you're going to use a parameter, subtracting that a statistic. And if you can't tell the difference between the two, then you are not going to do very well. So, anyways, we did some of this already. You don't have to cover that. We already told you this. If you don't remember, then, okay, these are both means, but one's a statistic, one's a parameter. These are both proportions. One is a parameter, one's a statistic. And someone asked me, hey, where's this P coming from? Okay. Understand, there's two types of data out there, right? What are the two types of data? Quantitative. If we're working with quantitative data, then these are the values you're going to use here. If you have qualitative data, it doesn't make sense to find the mean, but you can find the proportion of them. So these are the values that you're going to use when you're working with qualitative data. Okay? So that's where that comes in. Let's take a look at these problems right here. And you're going to want to be very careful with what you're talking about here, because sometimes you're almost saying the same thing, but it really isn't. Okay? So from these problems, let's do the first one. We want to be able to identify the population, the parameter, the sample, and the statistic in each of the following sentences. Okay, so we've got 4 things to look at. You are excused. The Gallup poll asked a random sample of 515 U.S. adults whether or not they believe in ghosts. Of the respondents, 160 said yes. Understand? Okay, cool. Let's start with the first one. Let's identify the population. Who is the population here? U.S. adults. That's it, yeah, it's U.S. adults. Okay, the population is U.S. adults. We're interested in knowing how U.S. adults feel about ghosts, right? So what is the parameter? The parameter of interest. What is the parameter of interest?
People who believe in ghosts?
The proportion of U.S. adults that believe in ghosts. That's what we want to know, right?
So it'd be like 260 over 515.
Not yet. The parameter of interest, what I'm looking for, and there can only be one of two parameters here, guys. I'm either looking for the true proportion or I'm looking for the true mean. Obviously, this is not a mean problem because it's a category. So I'm looking for the true proportion of U.S. adults that believe in ghosts. Understand? Questions?
Yeah.
What is it? Once I process it, I'll ask. Next one. What is the sample here? 515 U.S. adults is the sample. Okay, that is a
So
sample.
we want to know how many people believe in ghosts, and we took 515 people.
As a sample.
And we're going to be like, all right, how many of this group believe in ghosts?
Correct.
Can you dumb it down for us like that? Or for me?
What?
thought I did.
No, because the true mean is.
Yeah, I think.
Well, here's the thing.
I don't.
Here's the thing, though. Let's look at the statistic here, okay? What is the statistic?
The amount of people that said yes.
It's going to be the p hat, okay? It's going to be the p hat. The p hat, stay. In this case, it's 160 of the 515 people that we picked. Okay? So, what the heck's going on?
So, okay, are you saying that's the proportion of people who said yes to Flipping Ghost out of 500%, basically?
Right, isn't this a statistic? Right. So the proportion of people from my sample was, now someone divide that for me, please. What's 160 divided by? I'm going to tell you right now. Give me a second, okay? What? Did it go away again? Nope. This writing is weird. What is it?
31%.
51?
31.
So 0.3.
Look what you did.
I think the ghost got a hold of this already.
Shut up.
0.31?
Believe in ghosts. Alright, mess around with ghosts.
Well, I got my.
Do you believe in angels? Do you believe in God?
Oh my god. Science.
Don't believe in you, no. Okay.
Just because I only believe in science.
Okay, it should be over distribution. It's all the possible groups that I can get from the entire distribution. Okay? So we might, I might want to look at the slide because it might be mistaken. So here's the thing. We are interested in U.S. adults, whether they believe in ghosts or not. That's my population. The parameter I'm looking for is going to be proportion. Okay? It's the proportion of people that say that they believe in ghosts. Okay, whether they believe in ghosts or not. Okay? The sample that I picked, how many people did I sample? I picked 515 for my sample. That's all I could get. Now, from that, remember, what am I interested in? Well, obviously, it's those that said yes, because that's what they gave me, right? So I'm interested in the people that believe in ghosts. Of those people, how many believe in ghosts? 160 to 115. That becomes my p hat. That's a proportion from this sample that believe in ghosts. Now, why does that matter? That's statistics. Okay? If this should have been, if this was a random sample, that means that this group of people is representative of the population. So if 31% of this group believes in ghosts, then I can say 31% of the population believes in ghosts.
Well, wouldn't that be like subject to change though if you did more? Wouldn't it be subject to change if you sampled and surveyed more people?
Yeah.
What would happen? Well, obviously this is going to have some variability to it, right? But as my sample size increases, what's going to happen with my variability? It's going to get much more accurate. It's going to decrease. So yes. Okay? Now, let's say I discarded this and I got another 515 people. Am I going to get 0.31? Probably not. It might change. What's that due to? Sampling variability. Okay, very good. All right.
Wow, this actually kind of makes sense.
Let's take a look at the next one.
Nothing ever makes sense.
During the winter months, the temperature outside the Starnes' cabin in Colorado can stay well below freezing for weeks at a time. Stop.
I was telling him I need to focus. I was asking him to stop trying so I could focus.
Stop talking to her, dude. She needs another aid.
No, it's never Lumia's focus though.
I don't think I've said it, but that annoys me every time you do it. And I didn't want to say anything because you know how when you say it, then you do it more? But I hate that song. The Focus on Me song.
Oh, I know.
Because you do the whole...
And he sings the same line like 15 times.
It's okay, it's okay. It's a good song. No, it's not. It's not a good song. Okay, let's get back to this, please.
I like Olivia.
Let's take a look at the next example. So during the winter months, the temperatures outside of the Starnes cabin in Colorado can stay well below freezing for weeks at a time. To prevent the pipes from freezing, Miss Starn sets the thermostat at 50 degrees. She wants to know how low the temperature actually gets in the cabin. A digital thermometer records the indoor temperature at 20 randomly chosen times during a given day. The minimum reading is 38 degrees. So let's identify the population. It's the temperature. We're interested in the temperature, aren't we? Okay? Of what?
Outside the cabin.
In cabin. Inside the cabin.
Okay, so we're interested inside the cabin. Okay? Because if the cabin's warm, then the kind of heat, it'll keep the pipes from not freezing, okay? What's our parameter of interest? It can only be one of two things. And there's only one way it can start, which is with the word, the true or mean in this case. Not proportion. In this case, we're looking for the true mean. Because these numbers make sense for Addie, right? So we're looking at the true mean. True mean what?
Of sample?
The indoor temperature.
True mean of the indoor temperature.
So how do you tell the difference between the true mean and the true proportion? Or true?
A mean describes quantitative data.
And that's what we're trying to find here?
Right. I mean, do these fall in categories?
Yeah.
Yeah.
Well, I mean, I guess they kind of could, right?
It's more numbers.
Cold, colder, coldest. But we're actually taking temperatures. So I can take all those temperatures, add them up, divide by how many I have, and find a average temperature, couldn't I? So that is quantitative. The top example was qualitative in nature. Either you believed in ghosts or you didn't. I couldn't find the average of beliefs,
Okay.
right? So P hats are for proportions, which is qualitative. Yes. And then this is quantitative. Okay? What's my sample? What is it?
20 random
The 20 temperatures that I took throughout the day. And what's my statistic?
38 degrees.
And the minimum reading.
Wait.
No, your statistic is
50.
Wait, don't even tell me.
Wait, what was
50.
it?
But you said it at 50?
She sets it at 50.
You asking what the statistics is?
Yeah, that's the question, right? And what's the
Is it the
statistic?
32 between the 32 and the 0?
The statistic here is not posted.
It isn't, so
Okay.
there's one.
There is one. What would it be?
It's bringing the temperature.
It would be the average of the
Temperature.
20 temperatures,
Oh, and that just says the minimum.
right? And that's kind of to throw you off. All they gave you was the minimum one, but the statistic here would be the average of those 20 temperatures. Okay? Cool?
God, this makes sense.
Good.
I'm so
A little bit different. You'll do something in your book when I give you the homework problems, okay? Okay, a little bit more. Now we're going to practice differentiating between what is the statistic and which is the parameter. Okay? So look at the top one. Number 1. On Tuesday, the bottles of Arizona iced tea filled in a plant were supposed to contain an average of 20 ounces of iced tea. Quality control inspector sampled 50 bottles at random from the day's... What is that?
That's your grade.
Oh. From the day's production, and these bottles contain an average of 19.6 ounces of iced tea. So, there's a 20 and there's 19.6.
So the
What is 20? Is 20 a statistic or a parameter?
parameter?
It's the parameter, because that's what it's supposed to have, right? All bottles are supposed to have 20 ounces in them. Okay? So, the 19.6 is a statistic because it's based off of the 50 bottle what? Random sample. Good. This is from the sample of 50 bottles. What's my population of interest here?
The 50.
Bottles of Arizona iced tea.
What? Oh, okay.
That's what I care about, right? What do I care about? I want to make sure that they have
That sounds wrong.
20 ounces in them.
Subject?
No, that's the population. I know it would be easier, but that's not the vocab. The what?
Subject, I would have got that. Subject.
But in this case, it's the population of interest. Who are we interested in? Oh, we're interested in the Arizona iced tea bottles if they're filled correctly. Okay? Right? Let's take a look at the next one. On a New York to Denver flight, 8% of the 125 passengers were selected for random security screenings before boarding. According to the Transportation Security Administration, 10% of passengers at this airport are chosen for random screening. Okay? For starters, let's talk about the population. Who are we interested in? Passengers that are going to be flying, pretty much, right? Okay? What's our sample?
The 125.
The 125. Okay, the 125. Which is the statistic here?
The 8%.
The 10% that were chosen.
8%.
No, the 10%.
8% is the statistic. Okay, because 8% of the sample, 8% of the 125 were chosen, weren't they? How many people are supposed to get chosen? Is it only 8%? It's supposed to be 10. Remember, 10, that's a parameter because it doesn't change. We're supposed to be checking 10% of them. We only checked 8% of the 125. Right, that's the population parameter. We're supposed to be checking 10% of them. Did they do a decent job this time? No, but it can change. What's up?
Why don't they check all of the passengers? Like, isn't that what?
That would take forever.
Wait, is like the full screening like when you like take off your shoes?
Strip search.
That's when they take you in the little back room and.
Like there's a number like how much money you're
Right? Isn't that what it is?
Well, that's like part of it.
Because everybody goes through the machine, goes down there and looks like a moose.
The random
That's what they make you do, don't they?
They take you in a room and like search.
Be a moose.
But they don't. Obviously, they don't do that.
It's when they do like extra screening after.
Being on the ground.
We noticed that you were holding your briefcase with an underhand grip and not the overhand grip, so we're going to check you. Alright, cool. So, again, this is sampling variability. This is just saying that, for example, the Arizona iced tea bottles. We picked, what was it, 50 bottles? 20 bottles. 50 bottles. 50 bottles. They're supposed to have 20 ounces in them. Okay? So we picked 50 bottles. If I picked a different 50 bottles, am I going to get 19.6 ounces again? Average?
No.
Maybe. Maybe not. Okay? But every time that I pick a new sample, that statistic can change. Should a parameter change? Never. Okay? It shouldn't change. If it's changing, then that's a statistic. Moving on. Boop, boop. Okay, we talked about the distribution. Okay, let's take a look at this one here. This is just quick. I'm not even going to cover the rest of it. I don't like the rest of it. Suppose I have 200 chips in a bag. 100 of them are red. The remainder are blue. Then the population parameter of the chips that are red is 1/2. Because it would be, what, 100 over 200, which reduces down to half or 0.5. Okay? And it's a piece proportion, right? And it's a parameter. Okay? But why is it a parameter, not a statistic?
It doesn't have a hat.
Because it's all of my chips. I only have 200 bags of them. I only have 200 bags of
Me only
chips.
200
But it's
chips in a
all
bag.
of them. That's all the chips that I have.
Chips in a
And
bag.
that shouldn't change. Right. It's kind of like if I said, you know what?
Poker chips. Poker chips.
Oh, they're poker chips?
Yes. Red and blue.
Blue and red.
Why do you have
I just thought they were like the corn tortillas. Wow, we have some culture. I was like, why are they red and blue?
It's because you got barbecue and then you got the classics, right? Cool Ranch.
Store by 25.
Or were they Pringles?
Oh no, I like that one better.
Those are
The
chips.
nacho cheese and the Cool Ranch.
That's what I was thinking. I was like, okay.
You said they were.
No. No, I didn't.
Okay, so notice. So if I let a student randomly get 20 of those chips and tell me how many reds they got, then that would be a p-hat, wouldn't it? Make sense? Good. Right, it could change. If they throw them back in and then tell somebody else to come grab 20 chips without looking, then that proportion of red chips that they have could be different from the other ones. Okay? I know. It's actually kind of relaxing.
Doing that?
Save that for your meditation.
If you, I'm gonna start meditating.
Okay, low variability is better. Okay? If we can feel much more confident about the answer that we're getting, then that's a plus, isn't it? But what do we need to do in order to decrease variability? Increase sample size. Good. Sample size goes up, variability goes down. What's the downside of increasing sample size? Money. It costs you more to have a larger sample size. Whether it be more paper that you gotta do, or pay the workers to work longer to get more sample. But look at that. That's amazing. I love it a lot. Okay, we talked about these bad boys, so we should be good here. I think we're almost done. Here's a summary. I think that was good from this slide. If you want to grab your phone and take a picture, it'll last you longer than your notes. For some people. I love this part. iPhone to the sun.
And there he goes again.
Walter.
I
live
You got the pea hat? Important also. You know it's well, as soon as he's done with his picture,
Are you taking pictures?
we'll be done.
Oh, really?
There you go.
Let's take a
Not
selfie.
here. You need a cup?
Me?
She needs a hat.
She needs a hat. That was even better.
Wait,
Okay.
where'd the pea hat go? The helmet. The helmet that was bathing hat?
I moved it out. People were getting stupid with it.
Pea hat.
Let's get speaking.
They really pin the hat.
Oh my lord.
No.
Can you play that speaker now? I want to hear the music on it.